So when we're adding and subtracting rational expressions, we're going to use the same approach as we would with fractions. So we need a common denominator before we can add the numerators or subtract the numerators. So I'll go through a few examples here with fractions, and then we'll get into using variables. So here we have 2/3 plus 1/4. So I need a common denominator, and the lowest common denominator would be 12. And that means the first fraction here, I would multiply both the numerator and denominator by 4, and to get 8 over 12. And then the second fraction, I multiply numerator and denominator by 3. So I have 3 over 12. And I end up with 11 over 12 because I had the numerators. So pause the video and see if you can do the one below. Okay, so you should get 19 over 12 for that one. Now the same rules apply, however we have variables in this case. So again, like we've been doing in the previous videos, we want to identify first any excluded values. So the first one here we see y cannot be 0, because we cannot have that. So as part of our solution we have to include that in there. But now we need a common denominator of 4y, which means that we'd have to multiply this first term, the numerator and denominator, by 4y. So we'd end up with 12xy over 12y. And we're going to subtract, in this case, the second one, we'd have to multiply the numerator and denominator by 3. So we're going to subtract 3 over 12y. And that would leave us with 12xy minus 3 over 12y. And there's one common term they have there where they all have a common term of 3. So we can divide 3 into each of those terms, and we'd be left with 4 minus 1. Sorry, we'd be left with 4xy minus 1 all over 4y. So pause the video and try the one on the right. And so this one we should end up with 8y minus 3x over 4x, and there's no more simplifications there. In this next one, we want to first identify the variables that cannot equal 0. So x cannot be 0, and also y cannot be 0, because either of that would make the denominator 0. And we have to see what we would need to multiply in order to have the lowest common denominator. In this case, we're looking for 2xy squared. That would be the lowest common denominator. And so that means we'd have to multiply this first term by y in the numerator and denominator to get that y squared. And then in the second one, we're going to have to multiply everything by 2x. So we end up with 4x over 2xy squared. And then we end up with xy plus 4x all over 2xy squared. And we see that all terms have an x in there, which we could divide out. Again, we've already stated that x can't be 0, so it is possible to do that division. And if we divide that all out to 1, we end up with y plus 4x all over 2y squared. So pause the video and try the one on the right. And we see in that case we get y squared minus 2x over x squared y. Again, as long as x and y are not 0. Now here we have rational expressions with binomials in the denominator, and what we'll end up doing is multiplying these together. That would be the lowest common denominator, and then we would multiply the other sides by that. So what I mean is, the first term here, I'm going to have to multiply this 1 by x minus 3, and then we end up with x plus 1, x minus 3, plus 2 times x plus 1 all over x plus 1 times x minus 3. And I'm just going to highlight something here. These parentheses are really important here. Not in this particular problem, but even here when I'm multiplying by the 1, especially when you get into subtraction, if you have these parentheses here, you can expand properly and do the subtractions properly. So just get in the habit of putting them in parentheses and then simplifying from there. So what we would do is expand those brackets and combine the terms together. So we'd have x minus 3 plus 2x plus 2 all over x plus 1, x minus 3. And then combining like terms together, that would leave us with 3x minus 1 all over x plus 1 times x minus 3. And here we can say that x cannot be negative 1 or 3. Those are our excluded values. We could expand the brackets in the denominator or leave them there. Both of those are simplified. So pause the video and try the one on the right. Okay, so you get 3x over x minus 2 times x minus x plus 4. And just make sure somewhere in your solution you have stated the excluded values for this expression. Number 5, technically as a fraction, is 5 over 1. And so if we want to write that with a common denominator, then we would multiply the numerator and denominator by the other one, which is 2x plus 1. So we'd end up with something like this, where we do 5 times 2x plus 1 all over 2x plus 1 plus 1 over 2x plus 1. And now we could do 10x plus 5 plus 1 all over 2x plus 1. And we end up with 10x plus 6 all over 2x plus 1. And from there, we can't really go any further. We could factor the top, but other than that, we will have to say our excluded value. And in this case, that would be x cannot be negative 1/2. But from there, because this 1 is here, they're not all even terms, so we can't simplify any further. So pause the video and try the one on the right. Alright, so here we get 5 minus 2x over x minus 2. And I just want to highlight this subtraction here, and this is why the parentheses are so important. So you have to subtract this, which means that the negative 2 distributes to all the terms, and then you end up with the correct answer of negative 2x plus 4, and it simplifies to this. So what we'll do is we'll multiply the denominators together, and that means we have to multiply the numerators by those same things. So what we'll end up with is 2x times 2x plus 3 all over 5x plus 4 times 2x plus 3 minus 6x times 5x plus 4 all over 5x plus 4 times 2x plus 3. And so I will expand these out. We get 4x squared plus 6x minus 30x squared minus 24x, and that's all over this single common denominator here. And then we'll collect the like terms, and we end up with negative 26x squared minus 18x all over 5x plus 4 times 2x plus 3. The other thing we need to do, we need to make sure we state the excluded values. So we will state that x cannot be negative 4 over 5 or negative 3 over 2. So pause the video and try the one on the right. So here we get 11x squared minus 17x over x plus 1 times 2x plus 4. And x cannot be equal to negative 1 or negative 2. Okay, we see we already have a common denominator, so what we need to do is combine the numerators together. And so we're going to have x plus 4 minus 2x minus 2 all over x squared minus 4. And we end up with negative x plus 2 all over x squared minus 4. One thing we could do is, to simplify this a bit further, is we could factor the denominator and the numerator. So I'm going to factor out a negative 1, and I end up with x minus 2. And the denominator becomes x minus 2, x plus 2. That's a difference of squares there. So I know that x cannot be negative 2 or 2, but both the numerator and denominator have a common factor of x minus 2, which I could divide out now, and I'd be left with negative 1 over x plus 2. So pause the video and try the one on the right. Okay, the answer for this would be 4x squared minus 8 over x squared plus 1, or you could factor the numerator. What you'll notice is there's no excluded values here because this denominator, x squared plus 1, there's no real solutions making that 0. So there is no excluded values in this case. Okay, in this next example, sometimes it's very useful to factor some quadratics before you start multiplying things together to find a common denominator, because sometimes you can find they have similar factors. So for example, if I factor out this denominator here in the first term, I end up with x plus 3 and x minus 6 minus x plus 2 over x minus 6. And so we see we already have an x minus 6 term, so we really only need to multiply the second fraction by x plus 3. And so what that would leave us with is 3x squared minus 1 minus x plus 2 times x plus 3 all over x plus 3 times x minus 6. And then I could expand those brackets there, and I would end up with 3x squared minus 1 minus x squared minus 5x minus 6 all over x plus 3 times x minus 6. And I would collect the like terms together to end up with 2x squared minus 5x minus 7 all over x plus 3 times x minus 6, with my excluded values being x cannot be negative 3 or 6. So before you add them together, make sure you factor any quadratics to see if you get any similar terms. So try the one on the right. And so we end up with negative 2x squared minus 3x plus 6 over x minus 9 times x plus 2, with x not being equal to 9 or negative 2.